Hello everyone, today we will be solving this question. A projectile is launched with a velocity of root 10 meters per second at an angle of 45 degrees. So u equal to root 10 and theta equal to 45 degrees with the horizontal. The ratio of distance and displacement is given by. So we know that for a projectile displacement is just equal to its range. So r equal to u square sine 2 theta by g. Let's take g as 10 meters per second here, 10 meters per second square. So putting in the values, we get r equal to root 10 whole square sine 90 by 10. So these cancel, root 10 square and 10, and sine 90 is 1, so r equal to 1. Now we need to find the distance traveled by the projectile. So let us make the equation of trajectory for this. We know that equation of trajectory is given by x tan theta by minus gx square by 2u square cos square theta. Let us substitute the values given in the question. So we get y equal to x tan 45 minus, let's take g as 10, 10x square by 2 into root 10 square is 10, and cos 45 is 1 by root 2, so squaring it we get 1 by 2. So simplifying, we get y equal to x minus x square, which is x into 1 minus x. We can clearly see that 0 and 1 are the roots of this equation. So our parabola is going to look something like this. This is 1 and this is 0. So now our challenge is we need to find the distance traveled by the projectile. So that is the length of the arc, length of this arc. How do we do that? So we need to use a bit of integration for this. Let us take a small element dx and a small element dy corresponding to this dx. So if we take dx tending to 0 and dy tending to 0, this part over here is pretty much a right angle triangle, and let this small distance traveled be dl. So if the values are very small, this will basically be a straight line. So this will form a right angle triangle with dx and dy as its sides. Using the Pythagoras theorem, we can find out that dl equal to under root of dx whole square plus dy whole square. But we know that y equal to x minus x square. So differentiating both sides, we get dy equal to 1 minus 2x dx. Now let us put the value of dy in this equation. So we get dl equal to dx whole square plus dx square into 1 minus 2x whole square under root. Let's take dx square out of the root. So we get dl equal to under root of 1 plus 1 minus 2x whole square dx. Let us expand this square. So we get under root of 1 plus 1 square minus 2 into 2x into 1 plus 2x whole square dx. Dx is not under the root. Which is under root of, this is going to be 4x square, and 1 plus 1 is 2, and 2 into 2x is 4x. 4x square minus 4x plus 2 dx. So now we have dl equal to under root of 4x square minus 4x plus 2 dx. Now in order to get L, let us integrate this on both sides. So we get integration of dl equal to integration of root 4x square minus 4x plus 2 dx. But what are the limits? So as we know from the graph, we can say that x varies from 0 to 1, because we just need to find this length. We just need to find this length. So here the starting element corresponds to x equal to 0 and the last one is corresponding to x equal to 1. So our limits of integration are x varies from 0 to 1. Now we don't need to integrate this. Let us go back to our question. What does it ask us? It should be of this form. So distance equal to integration of some function. So now comparing with the format given in the question, we get the format given in the question is integration f of x dx from a to b. So now comparing the question to what we get that f of x is under root of 4x square minus 4x plus 2. So we are asked to find f of 0. Now let us put 0 into this function. We get under root of 0 square, so 0 plus 0 plus 2, which is basically root 2, and that's the answer which we want. So the answer is root 2, and we are done.